Hello, everyone, and welcome to this explainer. Today, we are tackling an absolute masterclass. We're going to decode the Cambridge 9618 Applications of Artificial Intelligence module. Now listen, whether you are building foundational knowledge in the 0417, 0478, 0983, 0984, or 2210 syllabuses, or you are right here in the thick of the 9618 advanced level, this mindset is absolutely crucial. Principal examiners constantly report this specific AI module as the most misunderstood area of the entire syllabus. Why? Because students treat it like a fact dump. They memorize a textbook and just throw it all onto the exam paper. Today, we change that completely. We are going to teach you how to become a strategic symphony conductor. In an exam, it is not just the raw notes you play, it's exactly how you orchestrate them. Each paragraph should be an instrument in perfect harmony.
Okay, let's take a quick look at our agenda. We're covering 1. The AI Exam Challenge, 2. The Procedural Framework, 3. Critical Analysis and Evaluation, 4. Examiner Warnings, and finally, 5. The Ultimate Exam Strategy. Let's get right into it.
Section 1. The Discord, the AI Exam Challenge. Let's address the core issue holding so many students back.
I want you to really consider this fundamental question. Why is applying AI concepts to unfamiliar contexts so incredibly difficult? It happens every single year. Let me introduce you to two types of students. First, there's Alex. Alex overloads answers with raw computer science facts. Alex memorizes the entire textbook, but there's absolutely zero analysis. Then there's Sam. Sam gets nervous, rushes through the paper, and totally misses the specific requirements of the command words. The gap between simply knowing a fact, like Alex, and actually applying a concept to an unseen scenario, which Sam struggles with, is exactly where the vast majority of marks are lost in Cambridge exams. You might perfectly understand an AI principle in theory, like how a neural network operates, but the exam is going to give you a totally unique, real-world scenario you've never seen before. It's a true test of adaptability. And this right here perfectly illustrates the core issue. The Cambridge Assessment Framework strictly prioritizes analytical depth over superficial breadth. Think back to Alex, providing superficial breadth by just listing generic facts without any context. You will practically score 0 for that in the higher bands. Examiners demand analytical depth, meaning logical, structured, and evidence-based reasoning. You can't just skim the surface and hope to hit a key word. You have to dive deep into the specific scenario they've handed you. If the question is about an AI navigating a warehouse, your answer cannot just be about AI navigation in general. It must be completely anchored to the reality of that specific warehouse floor, the obstacles, the timing, everything.
So how do the absolute top-performing students achieve that beautiful harmony in their answers? Well, they operate on these 3 core principles. First, connected conceptual understanding. They don't memorize isolated data points. They understand how one algorithm influences another. Second, flawless application to unfamiliar contexts. They don't panic when they see a weird scenario, they thrive on it. And third, knowledge across cognitive domains. They seamlessly blend basic recall, practical application, and high-level evaluation into a single, cohesive argument. It's like building a bridge. You need the foundational facts, the structural application, and the analytical engineering to hold it all together.
Section 2. The Sheet Music, the Procedural Framework. Let's look at the actual mechanics of writing your answers.
Algorithmic thinking in AI isn't just about magically jumping to a final perfect answer. It's a structured journey. It requires following these 4 distinct logical steps perfectly in sequence. Step 1. Step-by-step decomposition of the problem. Break the massive AI challenge into tiny, solvable pieces. Step 2. Selecting the appropriate data structures, arrays, trees, linked lists. Pick the right tool for the job. Step 3. Efficient code implementation. Actually writing the logic. And step 4, rigorous testing, evaluating if the thing actually works. If you try to skip a step, the entire symphony falls apart. It's a procedural framework. Now, before we continue to the next crucial concept, subscribe to our YouTube channel, AC Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit that bell icon right now.
Okay, let's talk about the method mark strategy. This is a game changer. The Cambridge exams are heavily focused on practical application skills. This means examiners desperately want to reward you for your process, not just your final output. You are literally earning marks for extracting data from binary representations, performing the calculation step by step on the page, and drawing evidence-based conclusions. If you do all the math in your head and just write down the final number, and that number happens to be wrong, you get 0. But if you show your systematic process, you can still secure the vast majority of the method marks, even if your final calculation is slightly off. Show your work. Let the examiner see the gears turning in your head.
Section 3. Critical Analysis and Evaluation. Let's move to the true harmony of your argument, evaluating alternatives.
Now take a really close look at this table. This is your cheat sheet for capturing those elusive, higher-order marks. When an exam question asks for an evaluation or comparative analysis of AI models, you must explicitly identify both similarities and differences. And here is the secret weapon. Use comparative connectives. Words like whereas, conversely, similarly, or on the other hand. This forces your brain to structure the paragraph logically. Don't just describe Model A and then separately describe Model B. You have to smash them together and compare them directly. Draw conclusions on their relative importance, and always support those conclusions with specific context from the provided scenario. When a paper demands a justified recommendation, you must systematically assess these 4 specific elements to secure the top band. First, time complexity. How fast does the algorithm run as data scales up? Second, space complexity. How much memory does it eat up? Third, what are the edge cases? And finally, how do these combine to affect the overall performance? If you systematically check off these 4 pillars in your answer, your argument becomes practically bulletproof. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Section 4. The Conductor's Pitfalls. Examiner Warnings. Let's address the sour notes where everyone loses marks.
I want you to read this massive warning pulled straight from the principal examiner reports. The classic mistake is providing generic answers not specific to the question context. Listen, memorizing textbook answers and dropping them onto the page without anchoring them to the specific exam scenario will actively destroy your grade. It is the #1 reason smart students fail to get top marks. They give an answer that is technically true in the real world, but entirely irrelevant to the story the exam question just told them.
Let's see how this builds visually by comparing 2 approaches. On one side, we have the incredibly flawed answer. This student is rattling off generic definitions, maybe confusing cause and effect within the AI system, and just hoping something sticks. On the other side, we have the top-tier answer. This student is creating contextually linked arguments and safely navigating boundary conditions. They don't just say, the AI uses machine learning. They say, because the scenario involves real-time obstacle avoidance, the AI must prioritize low-time complexity over absolute accuracy to prevent collisions. See the difference? One is a fact, the other is a contextual argument.
If we distill years of examiner reports down, we get these top 3 mistakes. Number 1, confusing cause and effect. For instance, stating that a larger dataset automatically causes the AI to run faster, when in reality it might slow it down while improving accuracy. Number 2, forgetting boundary conditions and edge cases. What happens when the AI receives totally null data? What happens at the absolute extremes of the environment? You must address the extremes. And number 3, the ultimate sin we just talked about. Generic, contextless answers. Avoid these 3, and you are already conducting way ahead of the curve.
All right, let's do a quick mental challenge to test your active recall. Imagine an exam answer. It perfectly and flawlessly defines a complex AI search algorithm. The definitions are textbook perfect, but it entirely forgets to mention the edge cases relevant to the specific scenario provided in the prompt. Can you spot the flaw? Why does this lose crucial method marks? I'll tell you. Because without addressing the specific boundaries of the given problem, the student hasn't demonstrated practical evaluation. They've only demonstrated memorization. The examiner doesn't want a dictionary, they want an engineer. So how do we prevent falling back on those generic textbook definitions? Here is a fantastic study technique to try. Use a visual story method. Creatively encode these complex AI principles into a visual narrative in your mind. If you're studying neural networks, picture an actual network of rushing rivers and dams, representing weights and biases. This sensory encoding helps ensure that the concepts stick permanently in your long-term memory. When you get into the high-pressure environment of the exam, it becomes so much easier to dynamically recall that story and mold the core concepts to fit whatever unique, weird scenario the exam paper throws your way.
Section 5. The Final Symphony. Exam Strategy. Let's bring all these instruments together into one unified system.
By adhering strictly to this standardized 5-step sequence, your systematic processing will perfectly mirror the academic benchmarks the syllabus demands. Step 1. Identify key elements. Decode the command words in the scenario context immediately. Step 2. Apply relevant AI principles. Figure out which specific theory applies to this specific context. Step 3. Execute analysis with clear working. Remember the method mark strategy. Write out every logical step. Step 4. Verify your results. Do a quick sanity check. Does this answer make sense for the scenario? Step 5. Present in the appropriate format. Use those comparative connectives and structure your final argument so the examiner can't help but give you the marks.
Take a look at this quote. Top-performing students exhibit connected, conceptual understanding transferable to unfamiliar contexts. This statement from Cambridge basically encapsulates our entire explainer today. Success isn't about the sheer volume of facts you've memorized. It is entirely about the interconnected quality of your reasoning. Now, listen closely. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos.
So, I'll leave you with this final challenge. Are you ready to stop playing isolated single notes and start orchestrating your arguments? It's time to master the Cambridge AI exam. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGC to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGC and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.